Hello everyone, my name is Ritesh Gupta and you're watching the Pentester Guy. Today we'll be discussing a trivial vulnerability but which is not easy to find, that is race conditions. And for this specific video, I'll be covering a case study of bypassing an email verification while registering a user into a web application. And for supporting my POC, I'll be utilizing the Portswigger Academy module. So why we are studying this vulnerability? Though there are multiple test cases which could be possible, which aligns to this specific vulnerability, but I have aligned few of them under few categories such as business logic, broken access control, and broken authentication. So sometimes you have seen that in a shopping cart, you get the opportunity to add either a coupon or a gift card. So what if you can utilize a single gift card again and again, and you manipulate the actual amount of an item that you are going to buy or you are looking to buy? The next condition that we can check is, suppose you have 5 to 6 items in your cart, or suppose you have one item in your cart and you want to buy more. That means while the entire transaction or entire process is going on, you trivially add one more item and server process it on the same price. That means you are able to buy two items on a price of single item. It could be two different items, or it could be um, same item. The next is we generally see that the web applications implement anti-brute force logic where they either use captcha. So we can use the captcha values again and again for bypassing it. Or there could be another scenario where we see that a certain user is allowed to make a request either 3 to 4 times. Suppose that the ID gets blocked for a certain interval of time. So we are able to bypass that as well using the race conditions. And at the end, what I'm going to cover is bypassing the email verification during the account creation. So these are the potential vulnerability that we must check for into an application. That's why we are going to understand the concept behind this vulnerability. So what actual a race condition is. So I'll be covering in a bird eye view what I can say. So it comes under server side vulnerability. So it is a server side vulnerability where we exploit the working or handling of the server, how it handle the request that is being sent by the browser. And the main concept or the core is that if a server is handling multiple process at a time, or the configuration is not built that multiple processes can't be segregated at a time, so that is where we exploit or harm the logic to make it under a race condition. So for understanding the race condition, we need to understand some concept as well. So of course, when we send a request to the server using the browser, the server accepts the request and handle it and process it. Now, these entire process includes multiple steps where we must know about the concept of network latency, jitter, and internal latency. In a layman term, what I can say is that the network latency is the time taken that when we send a request and when it is received by the server. Okay. So now when you send a request to the server, there might be a possibility because of some external factors, the request is received by server in a different amount of time. Suppose the initial request got 320 milliseconds and the second request is received by server approx 400 milliseconds, or the third request is received by server approx 120 milliseconds. So what we see is there is a variation. So latency is something which aligns to this, and the jitter is the average variation what we see. So if we send approx 30 requests to the server, so the average of the variation of the time is considered to be the jitter. Now, so the post the request is received by the server, there is also an issue that we face, that server also takes time to process request. So that comes under the category of internal latency, the time consumed by server to process a request. It could be that some request you send is processed early, some request you send is processed a little bit late or consumes a little bit more time. So that's the internal latency. Post that, the thing that you see here, the exclamation mark surrounded by the circle, is the race window, and race window is the core thing that we need to understand or to find out whether the application is vulnerable to race condition or not. So how to find it? There are 3 stages to find it. The first one is predict, second one is probe, and then prove it. In the prediction state, what we do is we simply analyze the flow of the request and the time consumed by the request. So suppose there are two dependent requests. One is for registration, another request is for user confirmation. So the time frame between this request must be analyzed, that how the server is handling this request, what time is consumed by which endpoint. And in the proof section, what we do, we craft, then after understanding the request, we craft the request in a sequential or in a parallel manner, and then directly send to the server to analyze how server responds against that, against the normal, or what we can say a normal end user will send the request. So that's what we do in probe. And in the last section, proof, the name itself justifies that we simply craft the request in a group and deliver the attack to the server, and boom. Now the one thing you see is the probe is having a loop condition. So that is very trivial about this vulnerability, that you know this vulnerability exists, but sometimes you do not get the desired result. So but sometimes you do not get the desired result in a single shot. So the thing is, you need to send the payload, send the crafted request again and again, the crafted packet again and again, to get the desired result. So maybe it is not making sense right now, but when I'll be demonstrating the test case, it will make sense. Till then, hold tight. So there are two different request types. One is sequential, another one is parallel request. So this request type is derived from the burp suite tool itself, where the burp suite allows us to group certain number of requests, and when we send it, we can send it in a single connection and as well as a separate connection. So suppose you have 3 to 4 requests in a single connection, what burp suite does is it makes a single connection with the server, and post completing or initiating a connection, it gathers all the requests and send it in a single shot. While in terms of separate connection, even you group 4 to 5 connection in a sequence, each request is handled individually. That means one request is sent, now the connection will get closed. Now the second request will be sent and connection will get closed, and so on. But in single connection, the connection doesn't get closed. Once the connection is established with the server, the entire group of the messages is sent in the single shot. Now the second thing is parallel connection. When we say it as a parallel connection, what we mean is, suppose you have 20 requests. So what burp suite does is it works same as the single connection, but in this case, the number of requests are gathered in a single packet instead of making a connection. So in a single packet, all the requests is gathered, and there is a specific gate time. At reaching that gate time, all the requests is handled to the server. So that is what we do in sequence and parallel connection or request type. We'll see in the demo as well to understand what actually I'm saying. Now, the case study which I'll be covering is bypassing email verification in user registration. So using the image, what I want to say is that since we have seen that this was the network latency, this was the jitter amount, and post that this is the internal latency. And what we see here is the window where we will check for race conditions, right? So this image says or explains that, okay, so we have sent a number of requests. There is some latency, which internal latency, that is making the request slow. Some requests are handled slowly, some requests are handled very fast. But to reach a specific window, we have to delay these fast requests so that the server receives the request at a specific time, and the process at the server end will consider it as a single process instead of considering it as a multiple process. So now let's jump to burp suite. I'm using the community edition, and that is more than enough to find or exploit any race conditions. Okay, so we'll go to proxy, we'll open our browser. So I have this lab, let's segregate it. So this lab is named as partial construction race condition. So the lab says that the lab contains a user registration mechanism, and a race condition enables you to bypass email verification and register with an arbitrary email address that you do not own. That means in this case, we don't own email address but we'll utilizing it to bypass the um, email verification. Prerequisite before starting this is one must be aware of using turbo intruder, because that is something which we'll be utilizing and helping us to perform the race conditions or check the race conditions vulnerability. So we'll access the lab and we'll understand what actually the application talks about, and in the real life what we can consider while testing an application. So we'll go into the HTTP history and let the website gets loaded. So what we see is we have my account and registration page. Fine. So since we have been told to register an user, but using a email that we don't own. Okay, fine. So of course, email client has been given to us. So when we click on it, let's see what we get. It says that your email address is winner at the rate so and so, and all the mails that is being sent to this domain will be delivered here. Fine. So these are the users. We can use winner instead of using winner. I'll be using my name, Ritesh, and uh, Carlos is the user. What we can utilize. So and the password we'll be using hello. So before sending this request, I guess all the request was not relevant since the application was loading. I'll delete it. Though in the real life you need to understand the entire application, but right now with respect to this specific lab, that's not required. So let's see while registering a user what we see, what we get. Okay, so please check your email for your account registration link. Now let me refresh it. So the thing is, we have our email that has domain exploit and so and so. But here what we see is, let me go back. Here what we see is the email domain is something like gin and juice.shop. That is what was mentioned earlier, that you don't have access to that email and you have to use the arbitrary email address. That means a different one or a random one. So what the application logic says that only this domain is allowed. Suppose we have given any gmail.com and the password is hello. Let's see. So what we can see is we get an error. You must register with Jin Jude shop email. Fine. Now the front end part is over. Let's see what actually happened and what requests were sent to the backend. What we can see is that this is something interesting. User registration page where the post request is being sent with the specified payload or the credentials. Post that what we see is these are the images. Then we have email, of course, the email client which we trigger to understand what actually happened. Post that these are the JavaScript files, and we also have users.js. So to be honest, I've already gone through this, so I am already aware that this static users.js file is something which is going to help me. And the fact why specifically this is, even if you are testing in a while or doing a bug bounty, whenever we see something ending with users passwords, right, the even the JavaScript files, we do go through it. So this is the second thing. And again the svg files and the same JavaScript, the same register page, and nothing fruitful. Okay, so what till now what we have is the registration page. Okay, and the second is the static user JS file. Fine. So let's see what actually it is, what JS we receive. Is it, it's not a huge code, but let's see. So there's a constant create registration form. Okay, that's a function. So there's a function that is being called to create a form. Then we have a constant where we are defining, where we are calling user registration, an element by id user registration. Post that we are creating element, and the element is the input form field, what we can see. The mhm. And that is the username input form field. The similar is with email form field. That element is created with the label, then another. Okay, so what we generally see is when we see a form in HTML, we do see it, right? We have labels for any input, and that input has the type of text, and we have label to it, such as username could be a label for that specific input point. So in this case, the same is happening for the username, email, and the password as well. So, and there is also a button, create element button. Okay, so for submitting it, I get it. At the end, all the element type that has been created is appended into the HTML using the JavaScript. Post that, we also have another function that is confirm email. Now, this is something which could be helpful to us and is helpful to us. So there's a function, and there's a constant container document.get element by class name confirmation. Okay, so if we receive a dynamic HTML in a response, then there could be something which consists of having confirmation as a class name into that HTML format. And going under that, we what this code is actually doing is it is fetching the URL, Windows location href. Okay, fetching the URL and splitting it post the question mark. So suppose there could be a URL, say http www.demo.com. Post that, there could be a question mark and followed by other parameter and its value. The next code of line says that if there is a parameter and its length is equal to 2, that means there is some parameter that is being checked, and this is the format of if and else condition. So if that's true, then the element that is at position second, because we can say it's a kind of uh, array that is being sent. 0 is the initial position, 1 is the second position, though. So the value at, if there is any value at position second, then it will be passed to the query variable, else empty string will be passed. The same goes with this action variable. If the query, that means if in the query, if we got something from here and it is being passed in query, and if that query includes regex or something like token, then that token will be passed into this action variable, or an empty string will be passed. Post that, what we have is a form variable where the form is being created, a method is being created of post, and the action is okay. So the action is slash confirm followed by a question mark plus action. That means a token is being passed. So something, what we can conclude is just a minute. So what we can conclude is, this says us, suppose this is, there is some domain, post that there is a question mark, and if we have something called parameter such as abc is equal to some value random, or and we also have some value such as suppose abc, suppose red is equal to some other domain. Okay, other domain.com. So what we have is, we have one parameter with value and we have another parameter with some value. But here it is saying that we are going to call a specific endpoint, post that. So slash confirm will be an endpoint. Okay. And post that, what it says that there will be something called token, and it will be having some values. Okay. And at the end we have button. Okay. So we are hitting the button, and at the end the functions are being called. So that is what this logic tells us. Now, what we can understand is, till now, what we can conclude is, this JS tells us there is an endpoint for confirmation of user. Now, what we don't have in UI is, we are not able to confirm user, since we are not having access to this specific domain. email address, gin and juice shop email address. So what we have seen is, if we go to register user, let me send it to repeater, and if we send it, let me render it. Okay, you must register with this. Okay, so let's register with this domain and let's see how the application behaves. Carlos. So okay, so account already exists with the username. So on the same email, can we use another user? Okay, great. So what we can see is, even if the email is same and there is a whitelisting of this domain for an email, the username for same email could be different. But once it is registered, the username gets what we can say locked or considered already to verify. So what is the actual logic behind this? So there could be a possibility, and there is a possibility. What we can understand is, once we hit a request for a registration, the server accept our request, and post that the server process it and sends our email to the user, so that post interacting with that URL, the user ID will get confirmed. Okay. Now the race condition, as we have seen, that we have to first analyze it, then we have to probe it again and again, then we have to prove it. So now we'll be understanding the flow behind the wall, what actually is happening, and how we can identify a race condition. So as I already discussed, that there could be a possible scenario that one resource could be taking more time, or one request could be taking more time. Another request or call to endpoint must be taking a um, less time to process it by the server. We also saw that the JavaScript says that there is a call to a specific endpoint for confirmation of a user, and that is being called. Post that, the user gets confirmed, and what we see that, and what we have seen, that the structure looks something like this. Okay. So what we'll be doing is, since we are not having, or we are not uh, getting it in the HTTP history, since we are not having access to the arbitrary email, we'll be crafting a payload, or we'll be crafting a request for it. So what we can do is, simply we can send it to repeater again to craft a request, and this is not required, I guess. And the endpoint was something like confirm. So it will be confirm and token, where we'll be having some value, let's say 123, and let's hit a request to see how it is being handled. So okay, so the conclusion is, the endpoint is valid and the request is valid as well, and the token is being validated as well. So what could be happening is, when we have sent in request to the server would have utilized that request, registered a user with a username, and mapping a token, or could have been mapped a token to this specific user, and has sent an email confirmation link to the user to confirm it. So for confirmation, a token would be required. So we are not having access to the token. What could be a potential scenario? Either we can give some random token, so we have seen that it's an incorrect token. We can also send a blank value for it. So what we can say is, if we send a blank value for it, it says 403, we are not authorized for it. So there are different syntax when it comes to PHP. Even if you write something like this. Let's see. Okay. So the syntax is still valid. An array in PHP can be defined in different ways. So this is one of the way. We can also write it in a way like this, and we can pass the random value 1 2 3. So the error that we see is there is a transition from 4 3 to incorrect token array. Let's blank it and see whether we get 403. Okay, so now what we can say is still we are passing nothing and we are passing a blank array, but we are not getting 403. We are getting an error that is incorrect token. That means there could be some token that is getting mapped, right? There could be some token. We are taking assumption here. Now, this is very trivial about this vulnerability. Even in XSS, even in other vulnerabilities, we are pretty sure that okay, this is 90 to 95% chance we are going to get this. But in this, it is totally trivial. I mean, sometimes I even consider it more complicated than other issues, but fine. So what we understood up from this is that some random token is being picked and it is picked from an array. Fine. So we have now two requests. One is for registering a user, another is for confirming a user. So what if we register a user, and while the application is registering it and mapping a token to it and then sending a email to the end user? That means the application creates a user, step 1. The application creates a token and maps it, step 2. And in the third step, the application sends the email to the user to confirm it. Now what will happen if before reaching to step 3, that means sending it to user, while the server is registering a person and token is getting mapped, we are confirming it, we are hitting a request for the confirmation of a user? Is this a possible case that we can consider? So yes, this is the actual probe condition that we must consider, and this is how complex or trivial this issue is. So what we are going to do is, before the token is getting mapped or while into the process, we'll hit a request for confirming the user ID, since the username is the only thing which is getting mapped. And this can be done using different methods. So we'll be utilizing what I've already shown you, that we'll be utilizing the sequential and parallel connections to understand the logic, what actually is happening. So when what we can say is, if we send the request, what we can say is, uh, let me change it to another user, since the user is already registered. If we send it to user Ritesh 3, what we can say is it takes 402 millisecond to process it. And if we send the same request to this endpoint confirmation, it is taking less time. So if we again send it, Ritesh 4, let me send it, and it is taking 430 milliseconds. For this function, we have 291 milliseconds. What we can conclude is, this request is getting time to process. So the user registration is taking time, but the user confirmation is taking less time. So in the process of registering a user and getting a token mapped, we can hit a request for confirmation as well. Using a normal burp suit repeater, we can't do it. That's why we club the request into a single connection. We can perform it by hitting a right click on a specific tab, and we can add it into a new tab group. So I'll be using the new group, that is group 1, and I'll be adding both the request into this group. So we'll create it, and now here what we see is we get a different type of options, which I was talking about. We can send the group in a sequence, but in a single connection. We can send both of the request in a sequence, but with a separate connection, and we can send the group in parallel as a single packet attack. So what we'll be doing is, first we'll be using the very initial single connection in a sequence to see or analyze what actual how actually it behaves. So we'll be changing a username since it is already created, and let us send, and let's see what actually happens. So we see that okay, it got accepted. It took 389 milliseconds, and still the second request is taking less time. So there could be a possible, or there could be a possibility for uh, a race window. And what if we send it in a parallel? That means we already know that parallelly, what we say is two different requests are being sent at the same time. Okay, so the process is considered to be a single one at the server end. So we send it in this way, and let's see what actually happens. So now you can see there is a difference. You can see there is a 1/2 which says that this was the first request between two requests, which Bubsuit helps us to understand. And now we can see that it takes much less time, 327 millisecond, and we can say that it took 328 millisecond. That means for reaching a race window, uh, it helps us a lot to send two different requests coupled in a single packet, which is considered to be a single one by the server. Since we understand the logic, can we manipulate it, or can we by using this, can we exploit it? No, that could not be possible. The possible reason is we have already sent a request, and what we can say is, even if we use it, a single user name which gets sent is logged, and we can't use it again. We'll get a response that it is already registered, so we need to change it again and again. So for testing a scenario where we are able to change user again and again, and for each changed user we can send this request again and again, we have to use a tool that is Turbo Intruder, which is a kind of extension that we can use or install via the App Store or Bubsuit itself. I have already installed it, so we'll be utilizing directly that. For utilizing the Bubsuit Intruder, what we can do is, let me shorten this. What we can do is, we generally select the payload that we have to manipulate or that we want to manipulate, and give a right click post installation of the Turbo Intruder I'm talking about. Okay, so once you install it, just select the parameter value that you want to target, hit a right click, go to extension, go to Turbo Intruder, and send to Turbo Intruder. So once we send to Turbo Intruder, uh, we can see that we have the request, and the specific portion that we have targeted is replaced by module OS. That is where we will manipulate it. Now, those people who are already familiar with Turbo Intruder, it's well and good. Those who are not familiar, uh, basically you need to have a little bit of understanding regarding the coding with respect to what we can say Python, at least, to understand the logic behind it. This was the last code that is being used by me I was checking whether we are able to use Turbo Intruder to bypass or to get a race condition. So what I have utilized is the race single packet attack. Since we in the previous request type as well, we were sending the parallel request in a single packet attack, right? So the Turbo Intruder itself provides us multiple templates. So these are different type of templates which could be utilized in different type of scenario that we want to use. And post that, you also get an option to use the last code used. So last code that I've used is this code. So but for you, I'll be doing it from the initial, so that it will be helpful for you to understand what actually is happening and what could be manipulated. It is not much tough to craft any payload using the Turbo Intruder. So this video will help to understand that as well, that how you can craft it. So since we are using this specific payload, so what we can understand is there are two functions. One is the queue request, another one is handling the response. Okay, in the queue request, we are giving the target and the word list. Two parameter are being set, and there is a engine value where request engine is some function which which contains endpoint target dot endpoint. This is already pre-configured. It fetches from the request, what you see here, right? So so uh, I think that is not required. That is done by mistake. Let me close it. So this is what we were doing. So we have a variable called engine and request engine. There is some endpoint which is being sent into the parameter, and it is fetched from the above request that we have sent into the turbo intruder by the tool itself. Okay, the focus is that we were what we want, that we need a request where we can manipulate this again and again, and for each manipulated username we can send the confirmation endpoint request again and again. Okay, so let's go to turbo intruder again, and let me tell you the main code part. So forget about this, focus here. So what we wanted is to manipulate the username. Two functions that are most important to understand. Initial one is the engine.queue, another one is open-gate. Now, why these two specific functions? The queue function will queue your request. That means this request which we wanted to send multiple times. So we can, in the range section, we can tell the tool that, okay, we want to queue this request so and so number of times. Okay. And post that, do not send the entire request until and unless a specific gate is opened. That means suppose there is a horse race that is going to begin. Now, until and unless 1, 2, 3 and shot is not given, the doors are not opened. The same exact thing is happening here. You are queuing the 20 requests in a row, and post the gate open, all the request is sent at the same time to the server, and server handle it and process it as a single request. Okay, that's the whole crux this tool is utilizing. And now we'll be quoting the same. Now what we want to do is, we want to first of all we want to make a request as well, right? So first of all, let's code this. We want to make requests, quest, in how many times we have to make requests. Suppose we have 20 users. So for, let's say, for users, okay, for users in range 20, engine.queue. So request is being queued, and what is the variable that we want to queue is users, right? Now we can't queue it directly, since we need to give different usernames. So what we are going to do is, we are going to craft username, different usernames. So what we can do is, we can simply write username, and we can hit a string user plus, and we are going to change the type of users to string. Now what why we are doing is, since that will be a int type, we have to convert it into a string type to concatenate it with another string. So what we'll be getting is user 1. For 1 in range 20, we'll be getting user 0, user 1, user 2, user 3, and it will be stored in username. And now instead of user, we will pass it as a username. Now each time the username will be passed, this function says that for 20 users, make a queue request and keep it under a same gate. Once I'll open the gate, then only send all the requests. Okay, fine. So one condition is met. Another is that how we will hit a request for another condition, that is, we need to call another request, or request to endpoint is post confirmation token this and this, right? Let me copy it, and we'll go to turbo intruder again, and for that, let me define it. In turbo intruder, you can simply define a calling of request in this way, like confirm. So the variable name could be anything. So confirm, I'll be writing confirm underscore request, and we'll be passing the value into a 3 triple quote, for starting, and we'll paste it, another followed by three triple quote. Okay. So now what we have is the connection request to the slash confirm endpoint with the token array. Now we were calling again and again the initial request for different user. Now we'll be calling again and again for each user. We'll be calling again and again the same confirmation request endpoint call, right? So since we have to call it for each user, we have to make it a nested for loop. So for requests in range, and we'll call, let's suppose 10 times we are going to call it. Okay. So for each one user, 10 requests for confirmation will be sent in a parallel request. So for this, the same engine.queue, we are again queuing the request queue, and we'll be passing the same number of arguments, but what we are going to replace is, since we are going to call the confirm underscore request for each one. So the application is so the code is actually doing is for each request for each user, unique user, user 1, user 2, user 3, we are hitting again multiple request of confirmation, a followed request, what we can say to be precise, and once the gate is open, the request is being sent, the function is being called. So that's the all purpose of this code. Now you also see that we also have a parameter that is being passed as word list. But what if you have a a name of number of word list already have, you can simply pass the location of that word list from your local system into a variable called word list. But since we are utilizing it in a code itself, manipulating it, that's not required. Okay. So if so everything is set up now, let's hit attack to understand how server is going to handle it. So the functionality of turbo intruder is super fast. So what we can see is we got an error, Python error, check extender to full details, syntax error, mismatch input, expected, didn't, string this and this for request range. Okay, fine. So we can't go back, I guess, right? So we can cancel it and again do the initial request, do a right click, extension, turbo intruder, and it says that we are having issue with the syntax. Let's see what is the actual issue. Okay. So the mistake we did is target request is not required, since we have already defined it into a variable. It is going to fetch it again from the request, which is not required, unnecessary. Line 20 is required. We are not going to intend it. Let's do it, and I guess this will work now. Let's hit a attack, and Python error, check extender for full detail, trace back, most recent call, file string, line 1, module this, line 21, queue request name error, global name, confirm request is not defined. Fine, let's see what is not defined. So confirm request is not defined. Okay. Okay, get it. There was a spelling mistake. Oh, now it worked finally. So after doing a lot of debugging, what we can see that we have sent 220 requests, which was in a loop, of course, 10 individuals, I guess, 20 individuals, I guess, with 10 requests for each individual. So if we see, we have a number of 200 requests as well for user from user 1 to user 19. And if we sort it via length, what we see is, okay, we have 314, and let's render. account already exists. Now, okay, I get it. So for each user, we have already sent a request. So whatever the logic is implemented at the server, maybe it is using that to check. And if we check for each user, we are getting the same and account already exists for this user. So the number of requests is 3143 till that it's same. I guess we are going to get the same for 24. Okay, so for 2640, please check your email account. That's something different. So 2640 will be having same data for user 40. Okay, no, that's user 0, I guess, not 40. So the username is 0 is successful. So let's check it. Let's check it. Let's open the application and back to lab home and let's log in. And if we hit user 0 and the password that we put is hello, I guess, let's check that as well. Yes, hello. Let's log in. Great, great, great. So what we can say is we were able to register a user even we were not having access to this specific email id. This is an arbitrary email id and we haven't confirmed it, but we are able to create a user, right? And to solve this lab, what we are going to do is we can delete the user Carlos to solve the lab. So similarly, you can check for other number of user as well, from user 20 to 20, 50, or you can check for more users. And if you don't get the fruitful result, you have to run the same attack again. That means in race condition, it might be the case that yes, it is still vulnerable, but you have to reiterate the process to get the fruitful result. So now concluding the entire race condition logic and practical, that how we can bypass the user verification, email verification of a user in a user registration process. Now completing this lab to Carlos, let's delete, and yes, we have solved the lab. Congratulations to you and me for learning a new topic, and we'll be utilizing it to secure other application as well. Thank you.